ranks. It's just remember that whenever we have to compare the proportions, we have to apply the chi-square test, and if we have to compare the ranking order, we have to apply the test called Mann, Whitney, U, and both the tests comes under non-parametric category of non-parametric test. So I'll share my presentation to you. Uh, just it is visible, I think. Yes. Yeah. Compare independent proportions. That means we are going to compare the proportions instead of the mean or the median. For example, for this particular test, we are going to apply a test called chi-square, and this is the sign for the chi-square. It's not x square, it's chi-square. So, what was the rule for non-parametric test? One example I'm going to take, that we could test difference of proportion of high blood pressure between different BMI status. For example, in BMI, we have a three groups like yesterday: normal, overweight, and obese. And under the blood pressure, we have a two groups like normal blood pressure or higher blood pressure, like that. Clear? So, what was the rule says that if you don't have independent variable and you have only dependent variable, and dependent variable is given in the form of category, for example gender and the BMI containing three different categories, you can go for a test called chi-square test. And if you have a two variables, one is under independent and one is under dependent, and both are given in the form of category, for that also you can go for the chi-square test. Now, upon successful completion of this particular lecture, what you are going to learn, you will be able to understand that what do you mean by the chi-square test for independence. You will also learn that how this test will be applied by manually by using the contingency table. This is especially for the students, and for researcher, that how to apply the chi-square test with the help of software called SPSS. And we will also discuss here that how to write the results of a chi-square test for independence as per MLA style and the APA style. So, chi-square tests are classified basically into two different types, that goodness of fit and test for independence. First, I'll discuss the goodness of fit, and the test for independence will take afterward. What this test says, basically the type of data which we are going to use for this particular test should be category. Numerical data we cannot apply for the chi-square test. The data which we have generated with our research, it should be available in the form of category only. That means in gender we have a two different category, one is male and second is female. So what's the formula? The formula for the chi-square is sum of all in the bracket observed minus expected square divided by expected. Now, what do you mean by this observed, and what is this by mean by expected? Expected value will be given by a examiner to you, that this will be expected, which will be the outcome of any research, and observed value which you have observed during the experimentation. So the same expected value will be used for all the observation which we are going to see in the next slide. So four different steps we have to follow if you want to do it this test manually. First of all, what we have to do, for each observed number in the table, subtract the corresponding expected number, that is O minus E, that is observed minus expected. Then we have, in second step, we have to square the difference of both. Then in third step, we have to divide the square obtained for each cell in a table by expected number of the cell, that is O minus E square divided by E, which I have shown in the table. And after that, we have to do the sum of all the value of the formula, and this is called as a statistics for the chi-square. So this is the formula which what we are going to use, that chi-square is equal to sum of observed minus expected square divided by expected. So this is the formula, and this is the sign for the chi-square, and this is the sign for the sum of all, that is observed minus expected. Now I will briefly explain that what do you mean by the observed and expected. Like this, you are going to get during the examination that we have a five different students. We have a five different students, and each student is giving a particular numbers. For example, either it can be the score of the students or whatever. So you can take five different students, or you can take the example of five different samples, and these are the observations which we have observed here. So like this table they are going to give you in the examination, and expected value they are going to write in the paragraph. That expected value, for example, if any examiner is taking exam which is having the maximum marks, so maximum marks will be the 100 or something like that. So maximum expected marks will be 100, and out of 100 how much they have scored, like this they are going to give. But in chi-square, the expected figure can be the less than or it can be the more than. So when I have taken this example, I have found that expected number was found to be 14. So like this you have to enter 14 in all the rows. Clear? So once like this they are going to give you in the examination that you have a five different samples, and these are the observation. That means this is the numerical which they are going to give you in the exam. So what you have to do, and expected value they are going to give. So expected value you have to enter like this in a row. When you will enter all the expected value, you have the value of O, that is observed, and you have a value of E, that is expected. So you have to find the difference of both. What to do? O minus E, that is 9 minus 14, we got minus 5. 12 minus 14, we got minus 2. 16 minus 14, we got 2, 0 and 5. So O minus E is this we have calculated, and after that what we have to do, we have to scale the O minus E. So square of O minus E is this one, 5. Square is 25, 2 square is 4, 4, 0 and 25. And we have to take the sum of this. So sum of this was found to be 58. So chi-square formula represents that sum of all divided by expected. So expected value we know that it is 14. So 58 divided by 14, we got 4.14. So chi-square value which we have found, it is 4.14. So after calculating the chi-square value, we have to use a table called chi-square contingency table for the distribution to compare our value with the uh, value which we are going to take from the table. So calculated value will be compared with the value which we are going to take from the table. But how the table will be used, we know that confidence interval of those study is 95%. Cutoff point for this test is 0.05. So uh, even Ujala has asked the same question. So I will show that how the confidence interval of the study will be chosen. You can see in this table that confidence interval for any study, if we have taken 95%, so there will be a uncertainty level, that is 5%. That means chances of error will be the 5%, and cutoff point for the study will be 0.05. Clear? So if we have taken a confidence interval of 99%, chances of error will be 1%, and cutoff point for the test will be 0.01. But I have given you the example of clinical trial, that most of the clinical trials will be conducted at the confidence interval of 99.9. So chances of error there will be 0.01. So the cutoff point for their study will be very least 0.001. So this will be taken as a extremely confident. That means if you are going to compare A with B, so you can say you can extremely confident that A is causing B, that if you are taking this confidence interval, and if you are taking this confidence interval 99%, so that time you can say I am very confident that A is causing B. And if you are taking a confidence interval of 95%. So you can say I am highly confident that A is causing B. So academic research will be done at this level, which will be called as a highly confident, or the significance level or the confidence level of the study 95%. So after explaining this, I will come back to the chi-square test. So we have seen that we have calculated the value of chi-square. So how this value will be compared with the a value which we are going to take from the table. Here, right hand side, you can see that critical value of the chi-square distribution. And here you can see I have taken two example that cutoff point is 0.01 and cutoff point is 0.05. So at both confidence interval, we can see that sample size for this particular test I have taken how much it was 5, and that means which side was 5, that means total 5 observation we have taken. So degree of freedom for this test is n minus 1. So n minus 1 gives a value degree of freedom 4, that is 5 minus 1 is equal to 4. So in front of 4 we have to see that what was the value for 0.05 confidence interval value is 9.4, and for confidence interval 99.9 at the cutoff point 0.01 the value is 13.2. So we have to compare our value which we have calculated 4.14 with 9.4 and 13.2. For example, if you have taken a confidence interval of 95%, then you are going to compare only with the 9.4. Clear? So we will compare our value with this 9.4 and we can find our results. So what the result says, we do not reject the null hypothesis because 4.14 is less than 9.4. So whenever the value which we are going to calculate with the chi-square, it should be more than the tabulated value which we are going to take from the table. Here we got the value less than the tabulated value, so we can say that our null hypothesis was not rejected and result was found not significant. Clear? That means all the this group does not have the equal proportions. That means equality has not been given and equal proportion is not there. So we have statistically, how to write the result, we have statistically non-significant evidence at alpha level 0.05 and alpha level 0.01. See why I have taken these two, because in the table I have taken the value of 2, I have compared with 9.4, I have compared with 13.2 also. So I'm writing both alpha level 0.05 as well as the alpha level 0.01 to prove that null hypothesis is false, and degree of freedom for this test is n minus 1. This I have already told you. So like this you can solve the chi-square test manually. And how to do it with the SPSS. In SPSS, the same formula will be run behind the software. That is how to do it. As you know that it's a chi-square test, so we are not going to the option called compare. We have to click on analyze. These are the steps. Then click on the descriptive statistics and click on the cross tab. So cross tab is the command. Just remember, I'll repeat again. Cross tab is the command in SPSS to run the test called chi-square. You are not going to find any word called chi-square in the SPSS. You have to remember that cross tab is the command if you want to run the chi-square test. So move the variable. For example, I have told you that I'm going to take one example. I'm going to compare the BMI with the blood pressure. So BMI also given in the form of category, and blood pressure is also given in the form of category. So BMI which we have entered in the form of number, that I have converted into a category by a process called visual binding. So I have written visual bind. So those who are new viewers in my channel, they can see my previous video that how to convert the numerical data into categorical data by using the visual binding. So it does not matter in SPSS that BMI you can keep in row and blood pressure you will keep in column. You can keep the BMI in column and blood pressure in the row also. Then click on statistics, check Okay, then click on the chi-square. Chi-square option will be given. Then click on continue. And this is very important step. Step number 7. Click cell and check row. If you are not going to do this, it is not going to show the results to you. That means you are going to get a error while generating the output sheet for the SPSS. So you can screenshot these all the steps how to run the chi-square test in the SPSS. I will show in the slides to you. So how to do it? First, click on the analyze, then click on the descriptive statistics. If you click on the descriptive statistics, you are going to get a window, this window, and this window is having an option called cross tab, and cross tab is the command for the chi-square test in SPSS. If you click on the cross tab, you are going to get a chi-square window. Here on the top they have written cross tab. It's a window for the chi-square only, and left hand side you are going to get all the variables which we have made for our study. And see, this is the BMI where I have entered the data in the form of number, but after visual binding I have converted the data into numerical to a categorical, and this BMI variable contain the data in the form of BMI. That means BMI having three different groups. One is normal, overweight, and the obese. So how to do it? Blood pressure I am going to keep in column, and BMI I am going to keep in the row box. You can keep blood pressure in row also and BMI in column also. It does not going to matter anything. So add both the variable which you want to run in row and column. Then come to the next step. How to choose? Still we have not chosen that we are going to apply the chi-square. See, here I have already moved the BMI in the row and blood pressure in the column. After that you have to click on the statistics. If you click on the statistics, you are going to get a cross tab statistics window, and this is the option which you have to choose, that you want to run the chi-square test. You have to check this box called chi-square. Clear? So once you will check this box chi-square, you can proceed. You can click continue. This is very important step. Until unless you will not click you will not check this box, that means you have not chosen the chi-square test. So click on the chi-square and click continue. If you once you will click continue, after going into statistics, you have to click on the cell. That means you want to see the percentage of each group also. That means you have to check these two options. One is called observed and second one is the row. If you forget to check this option called row, that means uh, results will be represented to you, but percentage will not be shown. Only numbers will be shown, that how many person having a low blood pressure and comes under the normal BMI group, but it will not show the percentage. So obviously the result we have to write in the form of percentage. So it is very necessary step that you should check this box called sorry, row. So once you click on the row and click continue, and you are going to get a results of the chi-square. So chi-square results represents what? First of all, it is going to give you that which variable you have compared, which are given in the form of category. That means BMI you are going to compare with the blood pressure. Both variable are given in the form of category only. After that, it is going to give you n, how much number of sample we have enrolled in the study, that is 150. Valid percentage, it is giving 100%, that no data of any patient or any animal is missing. That means missing value is 0. So we can take this percentage only if any digits appear here in the column of missing. That time one more column will be appeared by the software called cumulative percentage. So in that time you don't have to take this valid percentage, you have to take the cumulative percentage. So just remember this thing. So this is called case processing summary of chi-square, and after that it is going to give you the cross tabulation. And here you can see we have got the percentage for each one, each group, percentage of first group, percentage of second, percentage of third. So if you have not checked that row option in the previous step, you are not going to get this row. Only you are going to get a count. Percentage is not be visible. So if you want to justify your chi-square test, that will be performed in the form of percentage only. You can represent your results in the form of percentage. So percentage is very necessary. So you can see that what we have found, it is showing the first variable is written on left hand side, that is BMI, and it is showing that how many groups we are having under the BMI. Under the BMI, we have a three groups. One is your normal, overweight, and obese. And on the top, we have a blood pressure. And under the blood pressure, we have two groups: the patient having normal blood pressure and the patient having high blood pressure. So you have to cross tab this table. That means X versus Y you have to compare. That means how many person are having normal blood pressure but they are overweight, that is 54, and how many person are obese but having the normal blood pressure, that is 8. So normal I'm going to take like this 8, and obese I'm going to take like this, and percentage of these patient was 21. So how to find the exact result and what should be written in the research paper, because whole table we are not going to add in the research paper. You have to see that what was the maximum percentage given in the table. So you are not going to count the total for x-axis and y-axis. What you have to do, only these six groups we have to see, because three groups we have under BMI and two groups we have under the blood pressure. So 3 into 2 is equal to 6. So we are going to look only these six groups only, that under the six group which is having the highest percentage, and that highest percentage will be written in the research paper or in the thesis. For example, highest percentage we are getting, that is 78.9. Clear? So that is under which group? That means person having high blood pressure and person under the obese category. So we can justify this thing, that if the person comes under the category of obese, he will have a high blood pressure. So there will be chances of having the high blood pressure, and the percentage for our population was found to be 78.9. So this 78.9 we are going to write in the thesis. So third table for the test is the chi-square statistics. What is going to give you? It is going to give the value of chi-square, like in the manually also we have calculated, which was found to be 4 point something. So like this, by the software also we are getting a value for the chi-square here, and this we have to see that what was the significance level of the test, and here we are finding that the significance level was found to be 0.001, which is less than the 0.05. So we can assume that we are able to reject the null hypothesis and the test was found significant. So how to write the results of the chi-square with the previous example? You can write as per MLA. It was pretty obvious that the proportion of obese groups. So here I'm discussing only one group which was found to the maximum number, and we have found the highest percentage. So I'm discussing only one group. How to write the result? It was pretty obvious that the proportion of obese group who had high blood pressure was higher. In the bracket, we have to write the percentage, which was the highest percentage in the table, compared to both the groups, normal and overweight. And this is the writing style which I have written in red color, that how the statistics of chi-square will be written in the research paper as per MLA. You have to write the sign of chi-square. In the bracket you have to write degree of freedom. Now see, degree of freedom we have got 2, and this is the value of chi-square 14.82, and the p-value was found to be exact p-value. You can write when you are calculating with the SPSS. You don't have to write at less than 0.05 or more than 0.05. So p-value was found to be 0.001. So you are able to reject the null hypothesis, and the difference was found significant. That means whenever the category of the BMI is going to change, it is going to change the blood pressure of the patient also. It does not mean that if person is having the normal BMI, the person will have the equal blood pressure. A person is having the comes under the obese category, they will have a equal blood pressure. So if as the BMI is increasing, the blood pressure of the patient is also increasing. So like this, you can compare two different categorical variable where you will have the uh, different categories. So in this example, under the blood pressure I have kept two categories, and under the BMI I have kept three category. So category can be more than 3, 4, 5 in the chi-square or in the contingency table. It is not going to affect, but the main thing what we have to remember, we are going to calculate the proportion, and this is the proportion which was found highest, clear, in the test. So like this, you can perform the chi-square test through SPSS and manually. So if you have any question regarding the chi-square test, you can send the mail to me, you can ask by WhatsApp, and don't forget to subscribe our channel. So within a minute, I'll take the another test called Mann Whitney U.